Okay, so we're going to construct a function, select the squaring function inside an 8x4 rectangle. Okay. You're going to still have the point in the center of the base. You're still going to have the points in the upper right hand and left hand corners. Start out by cutting the thing in half, both ways, and then make the rest of your lines, and then follow the rule for doing a basic squaring function. Over 1, down 2. Okay? And what you're going to get will look exactly like a squaring function, except it's going to be stretched out. So if you squash this down to 4x4, it'll look like a basic toolkit squaring function. Okay? This will be a vertically stretched toolkit squaring function. Okay, so well, we finished dividing this up. Cut this line in half, cut this in half, cut this in half, cut this in half. And then we have one line down here already. We cut this lower rectangle in half. We cut this rectangle in half. Probably blocking the camera. We cut this rectangle in half. And I think we go over 1 and down 2. I used glue. Okay, so we go over 1 and down 2. Over 1 and down 2. And then we go symmetric on the other side. And now we have a parabola. Did anybody guess what the formula for this parabola is? Well, before I do that, I'm going to add something that I could have easily asked you to add. I want to add the graph of the toolkit squaring function, because this is not the toolkit squaring function. Toolkit squaring function is constructed inside a 4x4 square, right? It's been stretched. You can see it's stretched, isn't it? It's higher than this one, right? Okay, so if I want to do it inside a 4x4 square, well, right here's the top corner of a 4x4 square. Top left, top right corner, right? There's got to be a parabola that goes from here down to here. Okay, well, we can go over 1 and down 2. We get this point down here. Now, I wasn't very careful when I drew this. My blue line should have gone through, my blue curve should have gone through this point, right? And I was low, so I was a little closer to this than I really ought to be. And I'm low over here, so it's going to get a little confused. So I'm going to ask you to do it right on your paper, okay? Because you probably did it more carefully than I'm doing it. Now we got to go over 1 and down 2, but we don't have a second line to go through because we haven't subdivided the 4x4 rectangle. We need 1, 2, 3, 4 lines, so we have to subdivide this thing, which gives us a point like here, a point like here, and then we have a point here, and I'm going to fudge a little bit. It looks something like this. Okay, that makes sense. Okay, so if the equation of this, I'll turn the recorder off in a second. We'll talk about it. If this one is y equals x squared, that's easy to see why it is. Okay. Then, what do you think the blue one is? Okay, we have 3 very interesting suggestions for this, okay? And then we have the right answer. And I appreciate all the suggestions because it'll let me talk about a few things. So I'll just mention most of what I mentioned, whatever I can remember, because it's been a couple of minutes and who knows. Okay. First suggestion was x cubed. Okay. Well, that's coming up. Probably for homework this weekend. I'll give you instructions for it. But the problem with x cubed is if you cube a negative number, you get a negative number. Okay. And you don't have any negative numbers in this, so we throw out x cubed. Still a good idea. If you did x cubed in just to the right here, it would actually go up to 8. Okay, because 2 cubed is 8. Okay, it would actually have this point, but it would be low at this point. Low at this point. It would go through this point. this point. Okay, so it's not far if you stick to positive numbers. It's a very good idea. Another one was x to the fourth. Okay, because this thing's twice as high as this, so it might make sense to double the exponent. Turns out that doesn't work. X to the fourth gives you a graph that's very, very much like the parabola, but it's flatter down here and then it gets steeper over here. Okay. So it looks a whole lot like a parabola, but it's flattened here and then it goes up faster. Okay. And we'll see that, but probably not for a couple of weeks. The other suggestion was, what was it? X squared plus 4. Okay. Now, x squared plus 4 works just fine for this point because that point will be on the graph of x squared plus 4. What are the coordinates of this point? What's the x coordinate of this point? Show me your fingers. Yeah, it's 2. If you go over here, it's 2. But it's a 4 by 8 rectangle. And then this is pretty clearly 8, right? So many of those suggestions did go through the point 2, 8. So again, good thinking, but not quite on. And then we got the right answer, which is 2x squared. Okay. Because all we've done is we've doubled all the y coordinates. If we stretch out the 4 by 4 rectangle, or the green, stretch it out to here, all the y coordinates are doubled. Okay. Doubles the y coordinates of this function. And if you graph it carefully, you can see that very easily. So take a minute while I look at a little bit more of your homework, which so far looks excellent. And try to make a careful graph of that and see how it works out. Okay, I want you to kind of show me how on these graphs, for example, this point is on the same vertical line as this point, right? Does the y value here look like it's half of the y value here? Well, mark a few points, both sides of the graph, and see if your y value seems to double. Draw a few vertical lines, a few new vertical lines, and see if those values really double. They won't be precise depending on how well you made your graph, but most of them look pretty good. They'll be close. Okay, so I think everybody's real good here. And I've looked at the homework and I'm real pleased. I see everybody made a really good effort and got at least 75% of it. And a lot of people got 100% of it, I think. I didn't look at all the details, so I can't verify that 100% thing. I can usually find something you did wrong. Not that I'm happy when I do, because it's much easier to grade something that's perfect. Okay. And I did mention there'll probably be a test. And the way the test will be done, it'll be in the testing center. And I'm going to email you. I've already got a set of problems for the earlier part of it. Just kind of go up through what we've done here. Okay. Just practice problems. And you can see what the problems are going to look like because problems are going to look like practice problems. Okay. And I'm going to send you an email, maybe a couple hundred problems. So do them all by Tuesday. Just kidding. No, you practice all you want. But mainly, I want you to see that, because most of the problems are things that everybody here, judging from what I see in your homework, can do quite easily. Okay. Some of them a little more challenging. And then we're going to do a little more stuff. Okay. But right now, tentatively, the test will go into the testing center next Thursday after class. Okay? Go to the testing center, show them your ID, and they'll let you use a calculator. They give you a calculator that you can use because most of you have devices that have a lot more than just calculators on, right? And yeah, I don't see anybody here that has any need to cheat. Okay. But still, I want everybody to understand that nobody's going to have the opportunity. Right. Could be somebody hasn't been to class in 3 weeks, slips in there and cheats the way through it if we allow it, right? Not likely to happen, but we have to be able to say we prevent cheating. Okay. So you have a calculator with no memory and no connection to the internet. Simple calculator. I recommend you go in there and ask them to borrow one just to make sure you know how to operate it. It's a little different than what you're used to. Straightforward, very easy, and nobody has ever told me they had a problem learning to use it, and I didn't see any evidence in any of the tests that anybody has ever had a problem using it. But if you do, ask them. Okay. If they can't answer, try to find me, but I'm not always around. Email me, whatever. And I don't think anybody's going to have a problem, but get used to the calculator because you go into a test, you don't want to be thrown. You don't want anything to distract you. You'll have unlimited time. Test will be designed for about an hour. I've known people to take 8 hours for an 1-hour test. Okay. They very seldom get anything significant done after the first hour, but they stay there. Okay. And sometimes they do. Sometimes people are so meticulous in their work that they write out a huge amount of stuff, which I love to see. Okay. And it just takes them a couple of hours to do a 1-hour test. And maybe some people just work slow and write everything out meticulously. It takes them 3 hours. Okay, so I'll actually give you a set of sample tests, possibly on Tuesday, but if not later than Thursday. Okay, actual sample tests. Okay, I'm going to generate probably 50 tests. Okay, and probably 30 of those will go into a testing center. There aren't 30 people in the class, but just to be sure there are enough. Okay, I'll give you copies of the other 20. Okay, and they're generated from the same problem bank, but the problems will be different on every test. Okay, they'll be of the same difficulty. You have the same average difficulty in the test, and that way I know that nobody's telling anybody else what's on the test. In the first place, you pretty much know what's going to be on it if you look at what I'm going to give you. Okay. In the second place, I hope nobody's dumb enough to tell anybody else what's on the test. Okay. But if it's somebody else who can blackmail you, maybe. So make sure you haven't ever done anything that could be blackmailed. Got it? Good life lesson. Okay. Okay. And then put the blue graph inside. Okay. So again, picture here. You can change the dimensions of this thing. You can put the x-axis way down here. Put y equals 10 way up here. Put x equals 10 wherever you like. But once you have those, I want you to put the red dot corresponding to about this position and estimate your values of h and k. Right. Then do a 4x8 rectangle with this point in the middle of the bottom. And then slop your parabola into it. Then I'm going to ask you to tell me what the equation of that parabola is, but first construct it. And if you know how to tell me what the equation is, you can go ahead and do that, but I'll say a little bit more about that because not everybody will necessarily pick up on it. Okay, here we go. We have to estimate the coordinates at this point. Now, on my graph, 0's here and 10 is here. Tell me, thumbs up if this is closer to 10 than it is to 0. Thumbs down if it's closer to 0 than it is to 10. And thumb across if it's equal. Okay, everybody's saying it's closer to 10, right? So you better not have a number less than 5. Okay, wouldn't make any sense. 0, 10. Okay, so tell me what you think that is. It's something between 5 and 10. Show me with your fingers. What do you think my coordinate is? I'm seeing a lot of 6s and 7s, and that's exactly what I hope to see. Okay? You know, halfway here would be this. Okay? Now here's 5 and here's 10. It's closer to 5 than it is to 10, and it's a lot closer to 5. So I'm going to split the difference on your estimates. I'm going to say this is x coordinate is 6.5. That's h. What's k? Okay. Here's 0. Here's 10. Is it closer to 10 or 0? Thumb up or thumb down? Closer to 10? Okay, closer to 0. Yeah. Okay, clearly. Now 5 is halfway between, so 5's about here, right? So 0's here and 5's here. What do you think k is? Show with your finger. Yeah, I would say it's more than halfway from 5 down to 0. Or, you know, a little closer to 0 than 5. If you want to use a whole number, and that's legal, even if you think it really is a fraction, we'll just call that 2. And of course, 2 is very convenient. Okay, we'll see why in a minute. Now, if I want to draw my 8 by 10 rectangle, well, where will this line go? Vertical line on the right side of the rectangle. If the red dot is here, how far to the right of the red dot is this going to have to be? Show me your fingers. How far to the right of the red dot is the right edge of the 4 by 8 rectangle? It's 2. Okay. So to get to this, we got to move over 2 units. Now on this graph, show me how big 10 units is in the horizontal direction. Is it this big? If you were to go up to the graph, you put your hands this far apart, well, that'd be way too big. That'd be from here all the way over to here. Okay? So you can even show me with your fingers. It looks like about that far. Now let's see how well I did. Ah, that's fine. Okay, there it is, right? Okay, it's this big. Okay, maybe your thumb to forefinger doesn't stretch that far. Okay, so maybe you got to use 2 fingers. Let's see how I did there. Ah, it's still low. Okay, but there it is. Now show me how big 2 is. This is 10. Show me 2. Okay, you know, here's 10. You go halfway, that's 5. And then go a little more than halfway, and that's 2, right? Okay. Of course, that takes a little intuition with numbers, but I think most of you have that. So we go over 2 units, which is about this far. Okay, so we go over about this far, and we get the right edge, which will be along this line. I probably didn't go far enough. When you do better than I did, because I always like to see you do better than I did. Now we got to go that far to the left. So maybe we'd be on this line. So this should be x equals, what would x be if I go 2 units to the right? Well, this dot is at x equals 6.5. I go 2 units to the right, I'll be at 8.5, won't I? So this line ought to be x equals 6.5 plus 2 equals 8.5. And this line ought to be x equals 4.5. I think I didn't make it wide enough, so I think I'm not going to get a real good picture, but you'll get a better one. Okay. So whatever your H and K estimate is, the right edge is 2 units to the right of that H, 2 units more than H. The left is 2 units less than H. Okay. Now, how high does the thing go? It's got to go 8 units high, right? How big is 8? Well, if this is 10, now it's in the vertical direction, then 8 is about here, right? It's just got to go up to about here. Now, actually, if this is at 2, 8 puts you at 10, right? So the way I've got it, which is not necessarily the way you've got it, but a lot of people do. A lot of people estimated 2 for this point. If you estimated 1, then you're not going to go quite to the y equals 10 line, are you? If you estimated 3, you go a little over the line. Okay? But now you've got the rectangle, and now we can sketch a parabola. Now you can always, do subdivision and stuff, but on this scale, it's kind of small, so it's a little hard to subdivide that. So I'm just going to slop it in there. Okay? Make sense? If not, I'm going to have it on video. Incidentally, let me ask about this. What's the equation for this curve? Well, I'm going to go back to the formula that I wrote. I want to relate it to this formula. Some of you did it intuitively because you did it for homework and you know how it works. Okay. And that's good. That's good. We want to take that even a step further. And I'm going to come back to this because I wrote that in red last time. And it should be something everybody's tattooed in their forehead backwards in temporary tattoo. So you don't have to look at it for months when you look at it in the mirror. Okay. Seriously, you need to ponder this until you really understand it. Okay. Applied to this. F of x is 2x squared. That's the function you're transforming, right? That's the blue function. What's f of x minus h? For my graph, h is 6.5, k is 2, right? So I just take this formula and you understand this visually. Everybody's done a pretty good job with the homework and has the idea. And I think that's really pretty wonderful. Okay, so we can replace this by x minus 6.5 plus 2. Okay. Now, you have your own H and K. Somebody has their hand up, so I'm going to pause here and see what I'm doing wrong. Okay. Got f of x minus 6.5 plus 2, right? And the question was, don't have to have a square in here. Well, that x minus 6.5 is going to end up being squared, but it isn't squared here. It doesn't get squared until you replace this x with x minus 6.5, and you get. Okay, so f of x minus 6.5 is 2 times x minus 6.5 squared because of this function, right? So this is okay, that's your f of x minus 6.5. The square doesn't start here. This formula works no matter what's in it. You could be raising your x to an aardvark, and the aardvark wouldn't appear here. It doesn't appear until you substitute this into the formula function. Okay? So try to understand that. It's a little weird, but after you've done a couple of assignments and functions, it becomes pretty clear. And then we, of course, have the plus 2, which is not part of the f of x. It's not part of the f of x because f of x or f of x minus 6.5 ends here. And then we got plus 2. Okay. Now, plugging x minus 6.5 here moves the graph over 6.5 units. Remember, we started with this graph with the red dot at the origin. Replacing x by x minus 6.5 moves it over to here. And then up to here. And of course, I didn't put my red dot in this picture. I showed it out. Not sure how well that's going to contrast with purple. Got it? So, this video is not all that long. It's well worth looking at this part of it. Okay. And hopefully I'll be able to post a YouTube video. YouTube was, Tuesday was my day for terrible technology. YouTube lost its mind for a while. So I had to post some Zoom videos. Anyhow, here we got it. All right. And this is pretty much what people were writing. Hopefully that makes sense. And that is pretty much what everybody was, most of you were writing for the function, okay? Because you did it for homework and you got it there. If you didn't get that part on homework, go back and look at it again. Make sure you see it. If you try it and it doesn't seem to be working, you can always send me a copy of the scan. I'll tell you what I see, tell you what I want you to think about, okay? Now, hang on for a minute, because we still got 5 minutes, and we're going to use it. Okay, the y equals 2x squared function here, for the blue graph. You see this point that I've marked? Well, actually, it's not one of the blue points. Take this blue point right here. Okay? Don't say anything yet, but in a minute, I'm going to pause the video and ask you to tell me what you think the coordinates are. Okay, we did a little bit with this. This is a line y equals 4, that's clear. We cut this rectangle in half, we get the line y equals 2, right? Then we cut this in half, and we get this line that doesn't have a point on it. It does have a point for the green graph. Then we cut it in half, and we get to this point. What's y equal here? Well, I drug it out of most of you. It's y equals 1/2. What's the X coordinate? Well, what did we do? How did we construct these lines? We took this distance and cut it in half. This distance is 2, so this distance is 1. So X is 1 on this line. And what's X on this line? Well, it's 1/2. Okay? I want you to understand this because I'm going to ask you to do it on your homework because you always look at the video. So let's start with this point. What's the X coordinate? -2. What's the Y coordinate? 8. Okay, so we have -2 and we have 8. Okay. Now I should be able to list the rest of the coordinates without doing any calculations. Then you can say, okay, well, oh, that's the worst looking H I ever written. Okay, I wrote it small, but I wrote Y equals 2x squared. X is -2. You plug in -2, you square it, you get 4. Multiply that by 2, you get 8, right? So the arithmetic agrees with what you see on the graph. And I want you to get very good at checking that your arithmetic agrees with what you see. So I want you to see these before you do the arithmetic. Okay? So make sure you do it that way. You get better and better at seeing what a graph is telling you and what the characteristics of the graph are. There'll be some questions like that in your homework, which I hope to send out tonight. It might be tomorrow.